The human body is an absolute marvel, isn't it? Just this intricate masterpiece of engineering, layers upon layers of systems all working together. Mostly in harmony sometimes, not so perfectly.
Uh-huh. Yeah, that's
But
right.
imagine for a moment being able to actually kind of read that internal design, to feel the blueprint of your own structure, just using your sense of touch.
Mm.
Well, today, that's exactly what we're doing. We're taking you on let's say, a fascinating journey into that very skill. A journey to truly know your body, not just from a book, but tangibly.
It's often said, that anatomy truly comes alive with hands-on experience.
Right.
And that's precisely what we'll be exploring today. This deep dive is all about the art, and I guess the science too, of palpation. That ability to feel and identify structures beneath the skin.
Palpation. Okay.
It absolutely bridges the gap between theoretical knowledge, like looking at charts, and practical embodied understanding. It makes abstract diagrams into something you can actually feel, something that clicks.
Exactly. Think of it like a shortcut to really understanding how movement happens, or maybe why your body feels the way it does sometimes, or even just appreciating the incredible kind of silent engineering of your own skeleton.
Mm-hmm.
We're not just going to tell you what the bones are, though we'll do that too, but really how to find them, giving you, the listener, a sort of tactile roadmap to the hidden landscape of your own anatomy.
Yeah, making those abstract charts suddenly resonate with a tangible felt reality.
Right.
So our mission today is to equip you with precise, step-by-step guidance for palpating some of the most, let's say, crucial and illustrative bones and bony landmarks across the whole body.
Okay.
We'll be breaking down each selected structure, offering details on recommended support for the person being palpated, because comfort and relaxation are really key.
Super important. Yeah.
Definitely. And then prominent landmarks to guide your way, specific tracing routes, the right palpation techniques, and crucially, confirmation methods. Often involving movement, actually, to truly verify your findings.
So movement helps confirm.
Oh, absolutely. And insights into joint movements, or sometimes the lack of movement, that further help solidify what you're feeling.
Gotcha.
Now, obviously, we can't go through every single tiny bone in exhaustive detail in our chat today, but we've carefully picked ones that offer, the clearest entry points and the most profound insights.
Makes sense.
And just a note, for an even more comprehensive guide to every single landmark mentioned in our sources, remember to check out our companion resource on the Deep Dive website.
Great reminder. Okay, let's unpack this. Let's start with the very core of our structure, the axial skeleton, beginning right at the top with the skull. This is where it gets really interesting, showing you just how much you can actually discern with a sensitive touch. So, kicking things off with the skull, it's such a complex protective structure, obviously housing our brain. Let's begin with the frontal bone, that big, broad expanse of your forehead.
Right.
Now, when you're preparing to palpate this, you mentioned support is key for comfort.
Yeah.
How does that work here?
Absolutely.
Yeah.
So for the frontal bone, you'll want to gently support the person's head. Just place one hand under the occiput, that's the base of the skull at the back.
Okay, on the back of the head.
Exactly. This helps ensure their neck is relaxed.
Yeah.
And that's vital because, any tension in those neck muscles can subtly alter the position or even the accessibility of the skull bones.
Makes sense. And where do we start feeling? What's the landmark?
A great starting point, a really prominent landmark for the frontal bone is actually quite obvious: the eyebrows.
Ah, okay.
Specifically, you're feeling for the supraorbital margins, that bony ridge directly above each eye. That's your clear, easily identifiable anchor point. Perfect place to begin.
Got it. Suborbital margins. And from there, where do we trace?
From those eyebrows, the tracing route is pretty straightforward. Place your fingers firmly, but gently, right on those supraorbital margins. Feel that distinct bony ridge. Then just smoothly slide your fingers upward. Go along the broad, curved surface of the forehead for, let's say, about 5 to 7 centimeters. That's roughly 2 to 3 inches. Moving steadily up towards the hairline. You're trying to feel that large, smooth plate of bone.
Okay. Tracing upwards. And the pressure. How hard should we press?
The palpation pressure needs to be firm but gentle. The goal is to clearly feel the underlying bone, that smooth, unyielding surface, without causing any discomfort at all. You're mapping the landscape, not digging for treasure.
Right.
Yeah.
Map, don't dig. So it should feel like a big, continuous sheet of bone.
Exactly. And for confirmation, you'll know you're on the frontal bone if you distinctly feel that broad, smooth, slightly convex surface spanning the whole forehead.
Okay.
It should feel continuous with those supraorbital margins you started on, and crucially, it should be entirely immovable.
Immovable. Got it.
Right. And as for joint movement, well, it's not applicable here. That's because of the fused nature of the cranial sutures, those fibrous joints that lock the skull bones together.
Ah, the suture.
Yeah, they form this solid protective casing. Absolutely essential for the brain, of course. It's pretty remarkable how this one bone acts as a strong shield, but also, defines a big part of our facial identity and even houses the frontal sinuses.
Sinuses too. Wow.
Yeah, they contribute to vocal resonance. So it's this blend of robust protection and, well, subtle individual character.
Fascinating. Okay, moving on from the forehead then, let's explore the parietal bones. These make up a large part of the top and sides of the skull. Are they similar to the frontal bone in feel?
Indeed, the parietal bones are also all about robust protection. For these, again, support the person's head with one hand under the occiput. Try to ensure a neutral head position, so not tilted or turned.
Neutral position. Why is that important here?
It just keeps the cranial structures nicely aligned and minimizes any sort of rotational forces that could make palpation a bit more complicated.
Okay. And the starting landmark for these?
Your nearest prominent landmark is the external occipital protuberance. We'll get to that one specifically in a moment, but for now, just think of it as that bump in the midline, right at the base of the skull at the back.
That bump at the back. Got it. A central anchor.
Exactly. From that external occipital protuberance, gently trace your fingers upward. Go along the midline of the skull for about, say, 7 to 10 centimeters, roughly 3 to 4 inches.
Okay, tracing up the middle.
And as you do this, pay close attention. You might actually feel a faint ridge. That's the sagittal suture, where the two parietal bones meet in the middle.
Ah, the suture again.
Yeah. Once you've established that midline, gently move your fingers laterally, out to the sides, to explore the broad, expansive surfaces on either side. Those are the parietal bones.
Okay. And palpation pressure, same as before.
Pretty much, yes. Firm but gentle pressure. It's important here to distinguish the hard, unyielding bone of the parietal bones from the softer, definitely more movable scalp tissue.
Right, the scalp can slide around.
Exactly. So a confident but sensitive touch is needed to really feel the underlying bone structure.
And how do we confirm we're on them?
To confirm you're on the parietal bones, you should feel two large, rounded, firm surfaces forming the top and sides of the skull. As we mentioned, you might also notice that slight midline ridge where the sagittal suture is. And like the frontal bone, these structures are completely immovable. Again, thanks to those fixed cranial sutures. These bones essentially create the large vaulted roof and sides of the brain case. Pure protective architecture.
Makes sense. Okay, now let's talk about the temporal bones. These are on the sides, kind of below the parietals. Let's start specifically with the mastoid process. That's a really interesting, quite palpable landmark right behind your ear, isn't it?
It is, yeah. And it plays a significant role in muscle attachment and even inner ear stuff.
So how do we find that one? Support first.
Right. For this one, support the person's head with one hand under the occiput, but this time, gently tilt the head slightly away from the side you're palpating.
Tilt away. What?
It just helps to better access the area right behind the ear, makes the mastoid process a bit more prominent, and also helps relax any tension in the overlying sternocleidomastoid muscle.
Ah, that big neck muscle.
That's the one. It runs right over this area, so relaxing it helps.
Okay. And the landmark.
Your key landmark for the mastoid process is the external auditory meatus. That's just the opening of the ear canal. A very direct reference point right there.
The ear hole. Got it.
That's right. So place your fingers directly at the external auditory meatus, just behind the ear canal opening. From there, just slide your fingers downward and slightly posterior backwards for a short distance, maybe 1 to 2 centimeters, about half an inch. You'll feel a distinct bony lump.
Okay, down and back slightly. And the pressure.
Apply firm but gentle pressure to feel that distinct bony prominence. But be careful not to press too hard into the surrounding soft tissue. It can be quite sensitive in that spot.
Good tip. Sensitive area.
Yeah. It's relatively superficial, but still needs a delicate touch.
So confirmation, how do we know it's the mastoid?
You'll confirm you're on the mastoid process if you clearly feel a hard, rounded, immovable bony prominence located just behind and slightly below the ear. It's a fixed projection of the temporal bone, so no joint movement applies here.
Okay. Fixed point.
And what's fascinating about it is that it acts as this crucial anchor for several important neck muscles, helping with head movement and stability. Plus, it contains air cells connected to the middle ear, making it relevant for hearing and balance too.
Wow, a lot going on in that little bump. Okay, from there, let's try to go a bit deeper and explore another part of the temporal bone, one that's much more subtle. the styloid process? You mentioned this one's trickier.
Oh, it definitely is. A true test of your tactile sensitivity, this one. Support the person's head again with one hand under the occiput, and maybe tilt it slightly away again to help relax those neck muscles.
Why relax the muscles here?
Because those muscles can really obscure this deep, slender structure. If they're tense, it makes it almost impossible to feel.
Okay. And our landmark for finding this tricky little thing?
Your nearest prominent landmark is actually the mastoid process itself, which you've just located.
Ah, okay. Use the big one to find the small one.
Exactly, like a bigger brother guiding you to his smaller sibling. So, from the mastoid process, slide your fingers anteriorly, that's forward, and slightly upward for about 1 to 2 centimeters, less than an inch. You'll need to press deeply below the ear canal.
Deeply below the ear canal. Okay.
Yeah. This structure is more challenging because of its depth and all the surrounding tissue. You might not even feel a sharp point, maybe more like a deep, firm resistance under your finger.
Gotcha. So palpation needs care here.
Absolutely. Use firm but gentle, consistent pressure. Carefully try to locate this deep, slender structure. Extreme care is needed to avoid causing discomfort. It can be quite sensitive down there. And honestly, it might be very subtle, genuinely difficult to distinguish. Patience is key. Don't expect a huge, obvious thing.
Okay, patience. Confirmation. What are we feeling for?
You're looking for a slender, somewhat pointed, immovable, bony projection situated anterior to the mastoid process. Again, because it's fixed to protect it deep within the skull base, joint movement doesn't apply.
Still important, though, presumably.
Oh, yes. The styloid process serves as an attachment point for several muscles of the tongue and throat, so it plays a role in speech and swallowing. A tiny structure with significant function.
Amazing. Okay, next up for the temporal bones, let's find the zygomatic arch. This one's much more distinctive, right? It forms the cheekbone and extends back towards the ear, gives shape to the face.
Exactly. Much easier to find this one. For the zygomatic arch, support the person's head with one hand under the occiput and just make sure the face is relaxed.
Relaxed face, why?
Just prevents muscle tension, especially in the masseter, the main chewing muscle, or the temporalis muscles on the side of the head. If someone clenches their jaw, those muscles can kind of bulge and obscure the bone a bit.
Ah, okay. Makes sense. Landmark.
The most prominent landmark is the zygomatic bone itself, the cheekbone. Broad, easily palpable, you can't miss it.
Definitely not. So start there.
Yep. Place your fingers on the zygomatic bone, specifically just below the outer corner of the eye. From there, trace laterally outwards along that distinct curved ridge for about 3 to 5 centimeters, maybe 1 to 2 inches, moving back towards the ear. You're literally following the elegant curve of the cheekbone.
Okay. Tracing that curve. Palpation.
Apply firm but gentle pressure. Maintain good contact with the bone so you can clearly trace the entire arch. You should feel a consistent, solid ridge. Feels quite robust, actually.
And confirmation.
You'll confirm you're on the zygomatic arch if you feel that firm, curved, horizontal ridge extending prominently towards and eventually ending just in front of the ear. This structure is consistently immovable. It's a fixed part of the facial skeleton.
So no joint movement.
Correct. Not applicable. And this arch is a key attachment point for that powerful masseter muscle, essential for chewing. Plus, it plays a big aesthetic role in the contours of the face.
Definitely defines the face shape. All right, let's shift our focus now to the back of the skull, to the occipital bone. Big curved plate protecting the back of the brain, right? Where the head balances on the spine.
Exactly. To palpate the occipital bone, you'll want to support the person's head, maybe with both hands under the occiput this time, allowing for just a slight bit of neck flexion, tucking the chin slightly.
Why the flexion?
It just helps to bring the posterior skull into better palpation access. Gently stretches the overlying soft tissues, makes the contours a bit clearer.
Okay. And the key landmark for the occipital bone?
It's that external occipital protuberance again, that prominent bump right in the middle of the back of your head. Often the highest point you can easily feel back there.
That bump keeps coming up.
It's a really useful reference. So locate that external occipital protuberance. From that central point, just spread your fingers outward and upward, covering an area of about 5 to 7 centimeters, maybe 2 to 3 inches, in each direction. Feel the broad sweep of the bone, its gentle curve.
Okay, spreading out from the bump. Palpation.
Use firm but gentle pressure to feel that broad, curved surface. But do take care not to press too hard. This area can be sensitive because of all the muscle attachments and nerve pathways that emerge around there.
Right, confirmation.
You'll confirm the occipital bone by feeling a broad, firm, slightly concave surface covering the entire posterior skull. It should feel continuous with the protuberance and be completely immovable.
Immovable. Got it.
Just like the other main cranial bones, joint movement isn't applicable due to those fixed sutures. The occipital bone is essentially the heavy-duty back plate of the skull. It's the main point of articulation with your neck vertebrae and a powerhouse for muscle attachments that help control head movement.
Okay, let's really pinpoint that prominent bump we keep mentioning. The external occipital protuberance itself. It acts like a compass point back there, doesn't it?
It really does, a crucial landmark. For this specific point, support the person's head with one hand under the neck, gently encouraging just a slight neck flexion, like tucking the chin.
Why the flexion again?
That subtle movement just helps make the protuberance itself stand out a bit more, pushes it slightly back against your fingers.
Ah, okay. And a landmark to find it, besides just feeling for the bump.
Well, a reliable inferior landmark is the C7 spinous process, that vertebral prominence at the base of the neck. You can trace up from there.
Okay, trace up from C7. How far?
From C7, slide your fingers directly upward along the midline of the posterior neck and skull. About 5 to 7 centimeters, roughly 2 to 3 inches, until you reach the base of the skull. You'll feel for that distinct bump that really stands out from the curve.
Gotcha. And palpation.
Just firm but gentle pressure to clearly locate this distinct prominence. You're looking for something that really pops out from the softer tissues around it. A clear peak in the bony landscape.
Confirmation.
You'll confirm you're on the external occipital protuberance if you feel that distinct midline bony bump. Noticeably more prominent than surrounding tissues, and importantly, it should be immovable.
Immovable.
Since it's a fixed part of the skull, no joint movement. And this protuberance is important because it's where the neutral ligament, a strong band of connective tissue, attaches. Help support the head and neck.
Neutral ligament. Okay. Now, just lateral to that protuberance, you mentioned the superior neutral lines. Subtle ridges, you said.
Yeah, often quite subtle, almost like faint lines etched onto the bone. To find these, support the person's head with one hand under the occiput, and this time gently tilt it slightly forward.
Forward tilt. Why?
It helps to gently stretch the posterior neck muscles. Makes these ridges a bit more accessible so they aren't hidden under slackened tissue.
Makes sense. Landmark is the protuberance again.
Exactly. It's the central point from which these lines radiate outwards. So start right at the external occipital protuberance. From there, slide your fingers laterally, maybe 2 to 3 centimeters, about an inch, on each side of the protuberance. You're exploring a small area, just trying to feel for a slight change in texture.
Okay, small area, subtle feel, palpation.
Use firm but gentle pressure, but be particularly attentive here. You need to detect these subtle, often faint ridges. Really requires a delicate, keen touch. You might almost feel them as a slight change in the bone surface rather than a sharp edge. It's about distinguishing them from the softer neck muscles below.
Okay, delicate touch, confirmation.
Confirmation comes from feeling those subtle horizontal ridges extending laterally from the protuberance. They should feel distinct from the softer neck muscles and be immovable.
Fixed position.
Yep, fixed position on the occipital bone, so no joint movement applies. And these lines are critical attachment points for muscles that stabilize and move the head, like the big trapezius and the sternocleidomastoid muscles.
Got it. Okay, we've definitely scratched the surface of the skull bones there, hitting some really key landmarks. Of course, the skull also contains other important structures like the sphenoid bone deep inside, the nasal bones, the maxillae forming the upper jaw.
The zygomatic bones we touched on.
Right, zygomatic bones. For detailed palpation instructions for all of those, definitely consult our supplementary guide online. But now let's move to another incredibly dynamic part of the axial skeleton, the jaw. Specifically the mandible, which is unique for its mobility. Let's begin with the mandibular angle, that sharp corner of your jaw.
Right, the angle. For this, support the person's head with one hand under the occiput and maybe gently tilt the head slightly away from the side you're palpating.
Tilt away again.
Yeah, this subtle tilt can just help define that sharp corner a bit more clearly. Makes it stand out.
Okay, landmark.
Your nearest prominent landmark is the mandibular body. That's the long, horizontal part of the lower jawline. Pretty easy to feel along your cheek.
The jawline itself.
Exactly. So locate the mandibular body, then trace posteriorly backwards along that lower jawline for about 5 to 7 centimeters, 2 to 3 inches.
Yeah.
Keep going until you feel the distinct corner where the jaw turns upward. That corner is the angle.
Got it. Tracing back to the corner, palpation.
Apply firm but gentle pressure to locate this sharp angle. It's important to try and avoid pressing into any soft tissue or, glands that might be present around there. Focus purely on the bony structure.
Okay, feel the bone, Confirmation.
You'll confirm the mandibular angle by feeling that sharp, typically right-angle bony corner where the body of the mandible meets its ramus. That's the vertical part of the jaw going upwards.
Ah, the ramus. Okay.
This angle structure itself is immovable. But here's a great additional check. Ask the person to actively open and close their mouth.
Okay.
The angle will remain fixed, which clearly differentiates it from the moving condyle that we'll discuss next. The angle is a strong point, provides leverage for those powerful chewing muscles, the masseter and medial pterygoid.
Got it. Angle stays put. Now, for that moving part, the mandibular condyle, this is part of your temporomandibular joint, the TMJ, the hinge that lets your jaw open and close.
Exactly, the hinge joint. For the condyle, support the person's head with one hand under the occiput. But crucially, ask them to relax their jaw completely.
Total relaxation. Why so important?
It's absolutely crucial for detecting the subtle movement of this joint. Any tension, any clenching will just make it really hard to feel the glide of the condyle.
Okay, relax the jaw. Landmark.
Your nearest prominent landmark is the zygomatic arch, which runs just above this area. It provides a nice superior boundary for your search, just in front of the ear.
Okay, below the arch, in front of the ear.
Precisely. Locate the zygomatic arch, then slide your fingers downward and slightly anterior forward, about 1 to 2 centimeters, less than an inch. Aim for that point just in front of the ear canal. This is the general location of the TMJ, often a little depression you might feel there.
Okay, palpation. Sounds delicate.
It requires firm but gentle pressure, specifically to detect any underlying movement. And yes, it's important to avoid causing discomfort, as this joint can be quite tender, especially if someone has TMJ issues. Focus on feeling the subtle shift, not pressing hard.
Subtle shift. Confirmation.
You'll confirm the condyle by feeling a small, rounded, bony prominence that moves distinctly. This is the key. Ask the person to actively open and close their mouth slowly.
Okay.
As they open, you should feel the condyle shift forward and downward under your finger. That movement definitively confirms its location within the temporomandibular joint. The movement is the confirmation.
Movement is key. Got it.
Yeah, that condyle's smooth articulation with the temporal bone allows for all the complex movements of chewing, speaking, yawning. Highlights the mandible's critical role in both basic survival and, well, social interaction.
Absolutely. Okay, finally, for the skull region, let's not forget the hyoid bone. This is a really unique one, isn't it? The only bone that doesn't directly connect to any other bone. It just floats.
Exactly. It literally floats, suspended by muscles and ligaments. Quite amazing.
How do we find this floating bone?
To palpate the hyoid, support the person's neck with one hand under the occiput, just keeping the neck relaxed. This allows for that free movement of the hyoid, which is its defining characteristic. Any tension will inhibit its slight give.
Relaxed neck.
Landmark.
Your nearest prominent landmark is the thyroid cartilage. That's commonly known as the Adam's apple.
This large, easily identifiable cartilage is your inferior reference point, a clear, firm structure just below where the hyoid should be.
So start at the Adam's apple.
Yep. Place your fingers directly on the thyroid cartilage, then slide upward about 2 to 3 centimeters, maybe an inch, pressing gently but firmly. You're trying to glide your fingers above the Adam's apple into a slightly softer space.
Above the Adam's apple. Palpation.
Apply firm but gentle pressure to detect this unique mobile bone. It has a distinctive feeling that really differentiates it from the firmer, more static cartilage of the larynx below it. You might feel a subtle U-shaped structure under your finger pads.
U-shaped, mobile. Confirmation.
You'll confirm the hyoid bone by feeling that small U-shaped bone that's distinctly mobile. And the definitive test. Ask the person to actively swallow.
Swallow.
As they swallow, the hyoid bone will shift upward and maybe slightly laterally. That movement confirms its mobility and clearly distinguishes it from the fixed thyroid cartilage below. That upward jump is its hallmark.
Very cool confirmation.
Yeah. And this floating bone is incredibly important.
Okay.
It anchors the tongue and several muscles involved in swallowing and speech. Shows how vital stability can be achieved even without direct bone-to-bone joint contact.
Okay, moving down from the skull now, we enter the intricate world of the vertebrae, our flexible core. This amazing column of bones is our central support, protects the spinal cord, and enables this huge range of movements. Now, instead of trying to detail every single process for every single vertebra, which would take forever,
Right.
let's maybe focus on the general principles and some key prominent landmarks that act as sort of navigational beacons down the spine.
That's an excellent approach. Yeah, understanding the general pattern lets you apply the same principles across the different regions, cervical, thoracic, lumbar. Let's start with the most obvious ones, the spinous processes. ridges,
Right.
STS. Those are the midline bumps you can feel right down your back, the most accessible parts of the vertebrae.
Okay, the bumps down the middle. How do we find them in the neck, the cervical spine?
For the cervical spinous processes, support the person's head with one hand under the occiput and gently encourage just a slight neck flexion, like tucking the chin a bit.
Why the flexion here?
It just helps to spread the vertebrae slightly, especially in the mid-cervical region, and makes those individual spinous processes a bit more prominent, easier to feel distinctly.
Gotcha. Landmark to start from.
The external occipital protuberance at the base of the skull is your clear superior starting point for tracing downwards.
That bump again. Okay, start there and trace down.
Exactly. Locate the external occipital protuberance, slide your fingers directly downward along the midline of the neck for, say, 5 to 10 centimeters, 2 to 4 inches, just following the vertebral column. You're tracing that line of distinct bumps.
Okay, palpation.
Firm but gentle pressure again to clearly locate these individual prominences. Just be aware they might vary slightly in size and distinctness from person to person.
Right, confirmation.
You'll feel a series of small, distinct, immovable prominences running down the midline of the neck. They're often most prominent at C2, near the top, and C7, right at the bottom.
G2 and C7 stand out.
Usually, yeah. And asking the person to actively flex and then extend their neck gently will make the spinous processes become more palpable during flexion. That movement of the surrounding soft tissues confirms their position.
Okay, flexion makes them pop out more. And speaking of C7, let's specifically target that one, the vertebra prominence. It's famously easy to feel because it's usually the longest, most distinct spinous process in the neck, right?
That's exactly right. It's called prominence for a reason. To find it, support the person's head with one hand under the occiput, again, encouraging slight neck flexion. That movement helps C7 become even more accessible and prominent at the surface.
And the landmark, how do we know it's C7 and not, say, T1 just below it?
Good question. Often, you feel downwards from the external occipital protuberance, and C7 is the first really prominent one you hit at the base of the neck. If you go lower, you'll feel the T1 spinous process, which is the first thoracic vertebra. C7 is usually the most prominent one before T1. Sometimes T1 feels quite prominent too, though.
Okay, so it's the most prominent one at the base of the neck.
Generally, yes.
Oh.
Locate that most prominent bump. Apply firm but gentle pressure to clearly feel this specific one. You're looking for the one that stands out the most in that transition zone.
Confirmation.
You'll confirm C7 by feeling that prominent, midline, immovable bony projection right at the base of the neck. It's distinct, usually more pronounced than the other cervical spinous processes, especially with active neck flexion. That flexion also helps distinguish it from T1, which might feel prominent, but often moves less distinctly with pure neck flexion compared to C7.
Ah, because flexion helps to differentiate.
It can, yeah. And C7 is a critical landmark, not just for counting vertebrae, but often for assessing neck posture and range of motion clinically.
Makes sense. Okay, transitioning down into the thoracic spine, the upper back. Do those spinous processes feel different there?
Yes, they take on a different characteristic. For the thoracic region, support the person's upper back by having them sit upright, maybe with just a slight forward flexion, like a gentle slump.
Why the forward flexion here?
That posture just helps to spread the thoracic vertebrae slightly, making the spinous processes a bit more prominent and easier to feel, separating them a bit.
Okay, and our starting point.
The C7 spinous process, which we've just identified, is the clear starting point at the base of the neck for tracing these downwards into the thoracic region.
Got it. Start at C7, trace down.
Exactly. Start at C7, slide your fingers directly downward along the midline for, 5 to 10 centimeters, 2 to 4 inches, following the vertebral column through the upper back. Palpation is firm but gentle pressure again. But note, they often angle significantly downward in the thoracic region.
Angle downward, unlike the neck ones.
Exactly. They're not as horizontal. They often overlap like shingles on a roof. This downward angle is a key feature of the thoracic spine, influencing its natural curve, the kyphosis, and its stability.
Interesting. Shingles on a roof, confirmation.
You'll confirm the thoracic spinous processes by feeling that series of bony prominences, often angled downward, that are immovable. Right. They're typically more prominent at certain levels like T2, T7, and T12.
Okay.
And again, asking the person to actively flex their trunk slightly forward will make the spinous processes become more palpable during this movement, confirming their position as the deep back muscles, the erector spinae, relax or stretch over them.
Got it. Now, can we pinpoint specific thoracic vertebrae? Like T2, you mentioned is often aligned with a part of the shoulder blade.
Yes, exactly. T2 is often level with a very helpful landmark. For this, support the person's upper back by having them sit upright, arms relaxed at their sides. Just a nice, neutral, relaxed posture.
Okay, and the landmark.
The nearest prominent landmark for T2 is the superior angle of the scapula. That's the upper inner corner of your shoulder blade. The very reliable landmark they often align horizontally.
Upper inner corner of the shoulder blade. Okay. We'll get to palpating the scapula itself later, I assume.
We will, yes, in the shoulder girdle section.
Yeah.
But for now, imagine locating that superior angle. From there, just slide your fingers medially towards the spine to the midline of the back, about 5 to 7 centimeters, maintaining that same horizontal level.
Okay. Slide inwards from the corner. Palpation.
Apply firm but gentle pressure to feel this prominence. It should be a distinct bump right on the midline at that level.
Confirmation. How do we know it's T2 and not T1 or T3?
We'll confirm T2 by feeling that midline immovable bony prominence that is precisely aligned horizontally with the superior angle of the scapula. And here's a great confirmation. Ask the person to actively shrug their shoulders.
Shrug. Okay.
T2 should remain fixed while the scapula moves upward. That confirms their alignment and that T2 is part of the spine, not the moving shoulder blade. T2 is important for understanding the mechanics of how the shoulder blade moves relative to the spine.
Very clever. Okay, next let's find T7, another important thoracic landmark you said, relevant for posture.
Yes, T7 is often used as a reference. Again, support the person's upper back, sitting upright, arms relaxed, helps with muscle relaxation.
Landmark for T7, another scapula point.
Exactly. Your nearest prominent landmark for T7 is the inferior angle of the scapula. That's the pointy bottom tip of your shoulder blade. Another key scapular landmark that aligns well horizontally with T7.
The bottom tip. Okay, so find that tip.
Right. Locate the inferior angle of the scapula. Slide your fingers immediately from that point straight across to the midline of the back. Again, about 5 to 7 centimeters, maintaining the same horizontal level.
Okay. Palpation.
Firm but gentle pressure to locate this prominence. Should feel like a clear, bony projection, usually quite palpable at that level.
Confirmation.
You'll confirm T7 by feeling that prominent midline immovable bony projection that aligns horizontally with the inferior angle of the scapula. And asking the person to actively flex their trunk slightly forward will make T7 become more palpable, confirming its position as the soft tissue shifts. T7 is a common reference point for many upper back assessments, especially posture and scapular stability.
Got it. T7 lines up with the bottom tip of the scapula. And finally, for the thoracic spine, T12. You said this is a crucial transition point to the lumbar curve, marking the end of the ribs.
Exactly. It's where the rib cage effectively ends posteriorly. To palpate T12, support the person's lower back by having them sit upright, arms relaxed.
Landmark for T12 involves a rib.
Yes. The nearest prominent landmark for T12 is the 12th rib, which is the lowest floating rib. It doesn't connect around the front. This provides a direct horizontal reference point.
Okay, the lowest rib. We'll detail finding that later.
We will, yes, when we cover the ribs specifically. But for now, imagine locating the 12th rib out to the side. From there, slide your fingers medially inwards, from the ribs straight across to the midline of the back, about 5 to 7 centimeters, maintaining that horizontal level. Apply firm but gentle pressure to feel this prominence. It's the lowest of the easily palpable thoracic spinous processes, usually the last one you'll feel before a noticeable shift to the larger, broader lumbar vertebrae below.
Okay, last thoracic bump, level with the last rib. Confirmation.
You'll confirm T12 by feeling that midline, immovable bony prominence located near the lower thoracic spine, precisely aligned horizontally with the 12th rib. And again, ask the person to actively flex their trunk slightly. T12 should become more palpable, confirming its position. T12 is interesting because it's a transitional vertebra. It shows characteristics of both the thoracic region above and the lumbar region below, and it's a major attachment point for the diaphragm muscle.
Fascinating transition point. Okay, moving down into the lumbar spine, the lower back. These vertebrae are generally much larger, more robust, right? Reflecting their role in supporting most of our body weight.
Exactly. They're the heavy lifters. Let's identify their prominent spinous processes, SP.
How do we approach these?
Support the person's lower back by having them sit or stand, maybe with just a slight forward flexion again. Leaning forward slightly helps make the lumbar spinous processes more accessible and easier to differentiate from each other.
Okay, landmark. Is there one that stands out?
Yes, the L4 spinous process is usually the very prominent landmark itself, making it an ideal starting or central reference point. It's often palpated in line with the top of your hip bones, the iliac crests.
Ah, L4 lines up with the hips, so find L4 first.
That's often the easiest way. Locate the L4 spinous process. From there, you can slide your fingers upward or downward along the midline for about 3 to 5 centimeters, tracing the series of lumbar spinous processes, L1 to L5. You'll notice they feel broad and somewhat square-shaped compared to the thoracic ones.
Broad or square, okay? Palpation.
Apply firm but gentle pressure to clearly locate these broad, robust prominences. You'll notice they feel quite substantial and much less angled downwards than the thoracic processes. They're more horizontal.
Got it. Confirmation.
You'll confirm the lumbar spinous processes by feeling those large, broad, immovable, bony prominences along the midline of the lower back, particularly prominent at L4. Asking the person to actively flex their trunk forward will make the spinous processes become more palpable during this movement, confirming their position. These robust structures bear significant weight and absorb a lot of impact, making them absolutely foundational to our posture and movement.
Okay, let's specifically home in on L4 then. That reliably prominent lumbar vertebra, often a key reference point for everything below it, like you said.
Exactly. Support the person's lower back by having them stand, maybe with their hands placed casually on their hips. This often helps relax the lower back muscles and provides an easy reference for the landmark.
And the landmark is the hip bone.
Yes. Your nearest prominent landmark for L4 is the iliac crest, the superior border of the hip bone. Drawing an imaginary horizontal line between the highest points of both iliac crests usually passes right through the L4 spinous process, or sometimes the space just below it. It's a superb guide.
Okay, top of the hip bones.
So, place your hands on the iliac crests. We'll detail finding the crest itself and the pelvic girdle section. Slide your fingers medially from the highest point of each iliac crest straight across to the midline of the back. About 5 to 7 centimeters, maintaining that horizontal level. Apply firm but gentle pressure to clearly feel this specific prominence right on that line.
Feel for the bump on that imaginary line. Confirmation.
You'll confirm L4 by feeling that prominent, midline, immovable bony projection that is precisely aligned with the highest point of the iliac crests. Ask a person to actively flex their trunk forward. L4 should become more palpable, confirming its position. L4 is a very common site for back pain and disc issues, unfortunately, making its precise location crucial for clinical assessment and understanding biomechanics.
Very important landmark then. Okay, next we move down to the sacrum, that large triangular bone at the very base of the spine fused together.
Right, the foundation. We'll start with the median sacral crest. This is essentially the fused spinous processes of the sacral vertebrae.
Fused spinous processes? How do we find this crest?
Support the person's lower back by having them stand, or perhaps easier, lie prone, face down, with their hips relaxed. This position exposes the posterior pelvis nicely, making the sacrum more accessible.
Okay, prone position, landmark.
Your nearest prominent landmark is the L5 spinous process, the lowest lumbar vertebra, which sits directly above the sacrum. You'll often feel a distinct step down from the prominence of L5 onto the flatter sacrum.
Feel the step down from L5.
Okay, locate the L5 spinous process. Slide your fingers directly downward along the midline for about 2 to 3 centimeters, maybe an inch, right onto the surface of the sacrum.
Palpation. What does this crest feel like?
Use firm but gentle pressure to detect this series of subtle bony ridges. They're often much less distinct and more fused together than the individual lumbar spinous processes above. It might feel more like a broad, slightly uneven surface or ridge rather than separate bumps.
Less bumpy, more ridge-like. Confirmation.
You'll confirm the median sacral crest by feeling that series of small, midline, immovable bony ridges that feel distinctly different, more fused from the broader, more separated lumbar spinous processes just above. And since the sacrum is a fused, fixed bone, joint movement is not applicable here. This fusion creates a really robust base for the spine and is essential for transmitting forces from the upper body down to the lower limbs via the pelvis.
Solid base. Okay, finally for the axial skeleton, and you stress caution here. The coccyx, or tailbone. Small bone, but can be a source of significant discomfort if injured.
Absolutely. Extreme caution and clear communication are vital here. Support the person's lower back by having them stand or sit, hips relaxed. But most importantly, ensure clear communication and explicit consent before palpating this very personal and sensitive area.
Right. Clear consent is paramount. Landmark.
The nearest prominent landmark is the sacral hiatus. That's the very base of the median sacral crest you just felt, the end point of those fused ridges on the sacrum. It often feels like a small notch or gap. This is the anatomical gateway down to the coccyx.
Sacral hiatus. Okay. Trace down from there.
Exactly. Start at the sacral hiatus, slide your fingers gently downward for about 2 to 3 centimeters, about an inch, aiming for a point just above the anal cleft, the gluteal crease. It's a very small, specific target area.
Okay. Palpation. Must be very gentle.
Utmost care. Firm but gentle pressure, trying to avoid any discomfort in this very sensitive area. You are looking for a small, distinct bone that feels different, perhaps pointier, than the surrounding soft tissue.
Okay. Confirmation. How do we know it's the coccyx?
You'll confirm the coccyx by feeling a small, triangular, and distinctly slightly mobile bony structure. That slight mobility is key, clearly separating it from the larger fixed sacrum just above it.
Slightly mobile. Interesting.
Yes. And for a definitive confirmation, you can ask the person, again with clear communication, to actively contract their pelvic floor muscles like performing a Kegel exercise. The coccyx may shift slightly forward or downward under your finger, confirming its unique, albeit limited, mobility.
Wow, that's a specific confirmation.
It really is. And this small remnant of our evolutionary tail, while seemingly minor, provides crucial attachment points for pelvic floor muscles and ligaments, supporting pelvic organs and playing a role in things like defecation and sitting posture.
Okay, moving on from the spine, let's explore the thoracic cage. That protective shield of bone around your chest, vital for protecting your heart and lungs, and obviously enabling the mechanics of breathing. We'll start right in the middle with the sternum, the breastbone, beginning at the very top with the suprasternal notch, sometimes called the jugular notch.
Right, that little dip at the base of the neck. For this, support the person's upper back by having them sit upright, shoulders nice and relaxed. This posture keeps the sternum accessible, not obscured by slumped shoulders, and gives clear access to the upper chest.
Okay, sitting tall, landmark.
The nearest prominent landmark is the sternal end of the clavicle, the medialmost part of your collarbone, right where it meets the chest at the top. You can feel those two knobs on either side.
Ah, the collarbone ends. Okay.
So locate the sternal end of one clavicle. Then just slide your fingers medially towards the midline and slightly downward, maybe 1 to 2 centimeters, less than an inch, right into that distinct depression at the very top of the sternum between the clavicle ends.
Into the dip. Palpation.
Just apply firm but gentle pressure to clearly feel this distinct depression. It's usually quite easy to locate, that clear hollow at the base of your throat between the collarbones.
Confirmation.
You'll confirm the suprasternal notch by feeling that shallow, midline, immovable depression located precisely between the medial ends of the clavicles. And since the sternum is a fixed bone, joint movement isn't applicable here. This notch is a really crucial surface landmark, often used in clinical settings as a reference point for structures deeper within the neck and chest, like the trachea.
Got it. Now, just below that notch, we have another key landmark on the sternum. The sternal angle, often called the angle of Louis. You mentioned this is a significant anatomical beacon.
Hugely significant, yes. Support the person's upper back again, sitting upright, shoulders relaxed, similar to how you found the notch.
Landmark to find the angle, use the notch.
Exactly. The suprasternal notch, which you just found, serves as your perfect superior starting point on the sternum for tracing downwards to the angle.
Okay. Start at the notch, trace down. How far?
Start at the suprasternal notch. Slide your fingers directly downward along the midline of the sternum for about 4 to 5 centimeters, roughly 2 inches. You're feeling for a distinct horizontal ridge, or sometimes it feels like a slight step in the bone.
A ridge or a step. Palpation.
Apply firm but gentle pressure to locate this distinct horizontal ridge. It's often quite palpable and feels like a definite change in the angle of the sternum.
Confirmation. How do we know it's the sternal angle?
You'll confirm the sternal angle by feeling that prominent horizontal immovable ridge. And here's the crucial link. It is precisely aligned with the attachment point of the second rib's cartilage.
Ah, that's how you find the second rib.
Exactly. It's the key landmark for counting ribs accurately, but it's also a reference for deeper structures, like the arch of the aorta, where the trachea splits, and the top border of the heart's pericardium.
Wow, a lot lines up there.
It's a powerhouse of anatomical information. And again, since the sternum is fixed, no joint movement applies.
Okay, now that we have those key landmarks, the notch and the angle, let's identify the main parts of the sternum itself, starting with the manubrium. That's the broad upper shield-like part, right?
That's the one, shaped a bit like the handle of a sword, hence manubrium. Support the person's upper back, sitting upright, shoulders relaxed.
Landmark, the notch again.
Yes, the suprasternal notch forms the superior boundary of the manubrium, so it's your primary landmark, defining its top edge.
Okay, trace down from the notch.
From the suprasternal notch, slide your fingers directly downward along the midline of the sternum for about 2 to 3 centimeters, maybe an inch or so, until you reach the sternal angle. That broad upper part is the manubrium.
Okay, palpation.
Apply firm but gentle pressure to feel this broad, flat surface. It should feel quite substantial under your fingers, like a thick plate of bone.
Confirmation.
You'll confirm the manubrium by feeling that broad, flat, immovable surface that sits above the sternal angle and is noticeably wider than the sternal body directly below it. As part of the fixed sternum, joint movement is not applicable. The manubrium, along with its attachments to the clavicles and the first 2 ribs, provides a really robust foundation for the shoulder girdle and the upper part of the whole thoracic cage.
Solid foundation. Okay, now let's talk about the ribs in general. These curved bones form that protective cage around our vital organs, heart and lungs, but they also have a really dynamic role in breathing, don't they?
Absolutely essential for breathing mechanics.
Yeah.
Now, obviously, we can't palpate all 12 pairs of ribs individually in detail right now.
Right.
But understanding the general approach is really key. Support the person's upper back by having them sit upright, arms relaxed comfortably at their sides. This posture allows for maximum rib exposure and helps keep the intercostal spaces. Those are the spaces between the ribs open and accessible.
Okay. And the starting point for finding ribs? The sternal angle, yeah.
The sternal angle is your best friend here, yes, because it's directly aligned with the second costal cartilage, the cartilage connecting the second rib to the sternum. That gives you a precise starting point for counting downwards.
So find the angle, find rib 2, then count down.
That's the strategy. Locate the sternal angle. From there, slide your fingers laterally just off the sternum to identify the second rib. Once you have that, you can gently trace downward and laterally, maybe 5 to 10 centimeters, 2 to 4 inches out, following the curve of the chest wall. You can literally count them downwards, rib 3, rib 4, etc., feeling for each individual rib and the softer space between them.
Okay, feeling the ribs and the spaces. Palpation pressure.
Use firm but gentle pressure to clearly trace the individual ribs. You should feel their curved, bony structure and then the distinct intercostal spaces between them. It's like tracing the bars of a cage and then the gaps.
Confirmation. How do we know we're feeling ribs and not muscle?
You'll confirm the ribs by feeling those curved, bony, relatively immovable structures with distinct intercostal spaces between them. But here's the great confirmation. Ask the person to actively take a slow, deep breath in and out.
Deep breath.
The rib should expand slightly, moving upwards and outwards with inspiration and then recoil downwards and inwards with expiration. That movement confirms their position and distinguishes them from surrounding muscle or soft tissues, which might tense but won't move in that specific bucket handle way.
The breathing movement. That makes sense.
Yeah, the ribs exhibit that slight movement with respiration, which is absolutely key to their function in breathing, expanding, and contracting the chest cavity with every breath we take. Now, for detailed palpation of specific ribs, like the very elusive first rib tucked under the clavicle or the floating 11th and 12th ribs at the back, our comprehensive guide has all the step-by-step instructions. But for now, let's transition to the exciting world of the appendicular skeleton, the limbs.
Okay, now we transition from the axial skeleton, the body's core, to the appendicular skeleton, starting with the shoulder girdle. This is really the foundation for all that incredible upper limb mobility we have, giving us the reach and dexterity we rely on every single day. Let's begin with the clavicle, or collarbone, focusing first on its acromial end. That's where it meets your shoulder blade, right? Out at the shoulder point.
Exactly, the lateral end. For the acromial end of the clavicle, support the person's shoulder by placing one hand maybe under their upper arm, just keeping it relaxed. This helps minimize muscle tension around the joint, particularly the deltoid muscle, allowing for clear palpation of the bone and the actual articulation. Muscles can sometimes obscure that joint line.
Okay, relax the arm. Landmark.
Your nearest prominent landmark is the acromion itself, which is the lateralmost projection of the scapula, the shoulder blade. It's the direct articulation partner of this end of the clavicle. It's basically the highest bony point of your shoulder that you feel.
Okay, the top point of the shoulder. Sign that.
Find the acromion. From there, slide your fingers medially, that's toward the midline or the neck, along the superior or top aspect of the clavicle for just about 2 to 3 centimeters, about an inch. You'll feel the distinct, somewhat flattened end of the clavicle bone right there. You're feeling the junction where the two bones meet, the AC joint.
Okay, slide inwards along the top of the collarbone. Palpation.
Apply firm but gentle pressure to clearly feel the distinct end of the clavicle. It should feel somewhat flattened, maybe slightly rounded, not sharply pointed, as it forms that joint surface with the acromion.
Confirmation. How do we know it's the end of the clavicle?
You'll confirm the acromial end by feeling that flattened, slightly rounded bony end that articulates directly with the acromion. And here's your movement confirmation.
Oh, for sure.
Ask the person to actively shrug their shoulder up and down gently.
Shrug. Okay.
The acromial end of the clavicle should move slightly along with the acromion at the acromioclavicular joint, AC joint. It's a subtle movement, but it confirms its position and articulation within that small joint space. This articulation is crucial for the broad range of motion we have at the shoulder.
Got it. Subtle movement at the AC joint. Next up, the scapula, the shoulder blade itself. This is a fascinating bone, you said, because it kind of floats on your rib cage, moved by this complex network of muscles.
It really does float, yeah. Let's start with the acromion again, but this time thinking of it as part of the scapula, that prominent part forming the very point of your shoulder.
Okay, the acromions is part of the scapula. How do we approach it?
To palpate these acromion as part of the scapula, again, support the person's shoulder by placing one hand under their upper arm, keeping it relaxed. Minimizes any muscle tension that could obscure this highly palpable bony landmark.
Landmark for the acromion.
Your nearest prominent landmark is the spine of the scapula. That's that highly prominent ridge you can easily feel running horizontally across the upper back of your shoulder blade, usually quite distinct.
Okay, that ridge on the back. Find that.
Locate the spine of the scapula. Trace laterally outward along that spine for about 5 to 7 centimeters, maybe 2 to 3 inches. Follow it all the way to its outermost point at the shoulder. That expanded, flattened end is the acromion.
Okay, follow the spine out to the tip. Palpation.
Apply firm but gentle pressure to clearly feel this prominent, broad structure. It should feel relatively flat and substantial, like a wide shelf or plate of bone at the top of the shoulder.
Confirmation. How do we know it's the acromion, part of the scapula, and not the humerus below it?
Good point. You'll confirm the acromion by feeling that flat, broad, bony prominence at the very top of the shoulder. For a movement test to differentiate it from the arm bone, ask the person to actively abduct their arm. That means lifting it directly away from their body out to the side.
Lift the arm sideways.
The acromion should remain fixed, stationary, while the humerus, the upper arm bone, moves beneath it. That confirms its position as a stable part of the scapula. The acromion provides critical protection for the shoulder joint below and serves as an important attachment site for the deltoid muscle, which gives your shoulder its rounded contour.
Fixed acromion, moving humerus. Got it. Okay, let's move to a deeper, more challenging part of the scapula, the coracoid process. You described this earlier as feeling like a crow's beak. Sounds tricky.
It is definitely a subtle, deep one, yeah. Requires a bit more finesse. Support the person's shoulder again, placing one hand under their upper arm, but this time have the arm slightly abducted, lifted slightly away from the body, maybe 15-20 degrees.
Why the abduction here?
It just helps to open up the subacromial space a little. That's the area just below the acromion, making it a bit easier to get your fingers in deep to access this anterior projection.
Okay. Landmark. Where do we start looking?
Your nearest prominent landmark is the acromial end of the clavicle, which serves as an excellent superior reference point, directly above where you're aiming to go, but more medially. Or you can think of it as being just inferior to the lateral third of the clavicle.
Okay, below the outer collarbone.
Start maybe near the acromial end of the clavicle or just below the clavicle in that outer third. Slide your finger downward and slightly medial towards the midline, about 2 to 3 centimeters, maybe an inch. You need to press deeply below the clavicle, often through the front part of the deltoid muscle.
Deep pressure.
Okay.
Palpation.
Yes, palpation for this requires firm but gentle, deep pressure to carefully locate this structure. It is small and often requires significant depth. It's definitely one of the trickier ones. It might feel more like a small, firm, deep resistance rather than a distinct sharp point depending on the person's musculature.
Okay. Confirmation. What are we feeling for?
You'll confirm the coracoid process by feeling a small, somewhat beak-like, immovable bony projection located anteriorly, deep beneath the clavicle and deltoid. As it's a fixed part of the scapula, joint movement isn't directly applicable. However, passively moving the person's shoulder, like gently abducting it further, might help you isolate it from the surrounding muscles by changing their tension relative to the bone.
Okay. Fixed point deep down.
Yep.
Still important.
Oh, very. This small projection is a vital attachment site for several important muscles, including the short head of the biceps brachiomuscle, the coracobrachias, and the pectoralis minor muscle. It plays a crucial role in shoulder and arm movements despite its small size.
Amazing. Okay, we've touched on some key parts, the shoulder girdle, the ends of the clavicle, the acromion, and that tricky coracoid process. For a detailed exploration of the other significant landmarks of the scapula, like its medial and lateral borders, the superior and inferior angles we used as spinal landmarks earlier, and its various fosses, like the supraspinous and infraspinous fosses where the rotator cuff muscles sit, please refer back to our detailed companion guide online. But now, let's transition down the arm to the upper limb itself, the structures that give us our incredible dexterity and reach. All right, let's start with the humerus, the upper arm bone. And right up near the shoulder, its most prominent lateral projection, the greater tubercle. You mentioned this is a powerhouse for rotator cuff muscle attachments.
Exactly. 3 of the 4 rotator cuff muscles attach right here. To palpate the greater tubercle, support the person's arm by holding their elbow, keeping the arm relaxed and perhaps slightly abducted, just away from their side a little. This helps expose the lateral aspect of the humeral head, making the tubercle more accessible and minimizing tension in the big shoulder muscles like the deltoid.
Relaxed, slightly abducted. Landmark.
Your nearest prominent landmark is the acromion, that lateral most point of the shoulder we just discussed. You can easily trace down from there.
Okay, start at the acromion, trace down.
Start at the acromion. Slide your fingers downward and slightly lateral outward, just about 2 to 3 centimeters, maybe an inch, towards the upper outer part of the humerus. You'll feel for a distinct rounded lump right there.
Okay. Palpation. How does it feel?
Use firm but gentle pressure to feel this prominent rounded structure. It should feel quite distinct under your fingers, often the most noticeable bony part of the upper arm, right near the shoulder joint itself.
Confirmation. How do we know it's the greater tubercle?
You'll confirm the greater tubercle by feeling that prominent rounded projection on the lateral aspect of the humerus. And here's your key movement confirmation. Ask the person to actively rotate their shoulder externally and internally.
Rotate an arm.
Yeah, like turning their palm forward and then backward, keeping the elbow bent, perhaps. The tubercle should distinctly rotate along with the humerus, moving under your finger. This proves you're on the head of the humerus, rather than the stationary scapula.
Rotation confirms it's on the humerus. Got it.
Exactly. And as I said, this tubercle is the primary attachment site for 3 crucial rotator cuff muscles: the supraspinatus, infraspinatus, and teres, minor, essential for shoulder stability and movement.
Okay, moving down to the elbow region now. Let's find the lateral epicondyle of the humerus. This is a common point of pain in conditions like tennis elbow, right?
That's the one. The origin for the wrist extensor muscles. Support the person's arm by holding their forearm, with the elbow slightly flexed, maybe 20-30 degrees. This position relaxes the soft tissues around the elbow joint, making the bony prominences more distinct and less obscured by taut muscles or the joint capsule.
Elbow slightly bent. Landmark.
Your nearest prominent landmark is the olecranon of the ulna, the bony tip of the elbow at the back. When the elbow is bent, the olecranon forms a clear triangle with the 2 epicondyles.
Okay, the tip of the elbow. Find that.
Start at the olecranon, slide your fingers upward and laterally outward towards the thumb side, about 2 to 3 centimeters, an inch or so, directly above the elbow joint line. You're feeling for a distinct knob of bone on the outer side.
Outer knob. Palpation.
Use firm but gentle pressure to clearly feel this distinct bony knob. It should be pretty unmistakable on the outer side of your elbow.
Confirmation. How do we know it's the lateral epicondyle?
You'll confirm the lateral epicondyle by feeling that prominent bony knob on the lateral side of the distal humerus. To confirm it's on the humerus, ask the person to actively extend their elbow, straighten their arm completely. The epicondyle should remain fixed, stationary, distinguishing it from any moving joint structures like the radial head just below it.
Stays fixed during elbow extension. Got it.
Right. And this epicondyle is the origin point for many of the muscles that extend your wrist and fingers, hence its relevance in conditions like lateral epicondylitis or tennis elbow.
Makes sense. Now, on the opposite side of the elbow, the inner side, we have the medial epicondyle of the humerus. Another significant bony knob, often even more prominent than the lateral one.
Often, yes, it tends to stick out a bit more. Support the person's arm again by holding the forearm with the elbow slightly flexed, just like for the lateral epicondyle. Keep those muscles relaxed.
Landmark, olecranon again.
Yep, the olecranon of the ulna still forms that triangular relationship. Useful reference point.
Okay, start at the olecranon.
Start at the olecranon. Slide your fingers upward and medially inward towards the pinky finger side, about 2 to 3 centimeters, an inch or so, directly above the elbow joint line. You'll likely feel a larger, more prominent knob here on the inner side.
Inner knob bigger. Palpation.
Apply firm but gentle pressure to locate this distinct, larger bony knob. It's often quite easy to feel. And be aware, sometimes you might feel a little tingling sensation if you brush against the ulnar nerve, the funny bone nerve, which runs in a groove right behind this epicondyle.
Ah, the funny bone. Careful there.
Exactly. Be mindful. You'll confirm the medial epicondyle by feeling that larger, prominent, immovable bony knob on the medial side of the distal humerus. Ask the person to actively flex their elbow, bend their arm. The epicondyle should remain fixed, confirming its stable position on the humerus.
Stays fixed during elbow flexion, okay.
Right, and this epicondyle is the origin for many of the muscles that flex your wrist and fingers, the wrist flexor group, making it a powerful anchor for forearm movement and grip, often involved in golfer's elbow.
Got it. Flexors versus extensors. Okay, moving down into the forearm now. Let's locate the head of the radius. You said this one is key because it moves distinctly. Makes it a great example of mobile palpation.
It really is a classic example. Support the person's forearm by holding their wrist with the elbow slightly flexed again, maybe 90 degrees is good here. This relaxes the muscles and allows for easier rotation of the forearm, which is crucial for finding this.
Okay, elbow bent, landmark.
Your nearest prominent landmark is the lateral epicondyle of the humerus, which is located just superior to the radial head. It's your guidepost just above where you're aiming.
Okay, find the lateral epicondyle, then go down.
Start at the lateral epicondyle. Slide your fingers directly downward, about 2 to 3 centimeters, an inch or so, onto the lateral aspect of the forearm, just below the elbow crease. You're feeling for a small, somewhat rounded structure in a little depression there sometimes.
Okay. And the palpation is special here. Involves movement.
Yes, this is the key. Apply firm but gentle pressure with one finger while simultaneously using your other hand to rotate the person's forearm. You hold their hand or wrist and turn their palm up, supination, and palm down, pronation. This active assisted movement is the absolute differentiator for the radial head.
Okay, rotate the forearm while palpating below the lateral epicondyle. Confirmation.
You'll confirm the radius head by feeling a small, rounded bone that distinctly moves or spins under your palpating finger as you passively rotate the person's forearm. That rotation definitively confirms its position within the proximal radial thenar joint. Feeling that spin highlights its crucial role in forearm rotation, allowing us to turn our hand over for countless tasks.
Feel the spin. Very clear confirmation.
Yeah.
Now for the other forearm bone, the ulna. Let's find its tip at the elbow, the olecranon. This is the classic point of your elbow, right? Very easy to find.
Usually very easy, yes. Support the person's forearm by holding the wrist, maybe with the elbow slightly flexed, say 90 degrees again. This position brings the olecranon into prominence posteriorly, making it easy to feel and often quite visible at the back of the elbow.
Landmark. The epicondyles again.
Yes, the medial epicondyle of the humerus, for instance. When the elbow is flexed to 90 degrees, the olecranon and the two epicondyles form that very clear equilateral triangle shape. Helps orient you.
Okay, that triangle. So find the medial epicondyle.
Start at the medial epicondyle, slide your fingers downward and posteriorly straight back, about 2 to 3 centimeters an inch, directly to the very back point of the elbow.
Palpation.
Apply firm but gentle pressure to clearly feel this prominent structure. It's usually unmistakable, feeling like a large, rounded, bony point.
Confirmation.
You'll confirm the olecranon by feeling that large, prominent, bony point at the very tip of the elbow. It feels quite substantial. And for movement confirmation, ask the person to actively extend their elbow, straighten their arm fully. The olecranon should feel like it moves snugly into the olecranon fossa of the humerus, that depression on the back of the humerus, confirming its position and articulation.
Moves into the fossa on extension. Got it.
Exactly. The olecranon forms the strong proximal end of the ulna and provides that crucial lever arm for the powerful triceps muscle to extend the elbow.
Makes sense. Okay, at the other end of the ulna, down at the wrist, we find the head of the ulna. This is usually quite visible and prominent on the pinky finger side of your wrist, isn't it? That little bump.
Often visible, yes, especially when you turn your palm down. Support the person's wrist by holding their hand, with the forearm pronated, meaning the palm is facing down. This maneuver makes the ulnar head pop up and become more prominent on the dorsal back aspect of the wrist.
Palm down makes it pop up. Okay. Landmark.
Your nearest prominent landmark is the styloid process of the ulna, which is a smaller, pointier bit directly distal towards the hand, to the head. You'll often feel the rounded head first, then the sharper styloid just below or slightly behind it.
Okay, find the styloid. Go up slightly.
Locate the ulnar styloid process. We'll do that next. Slide your fingers proximally towards the elbow, just about 1 to 2 centimeters, less than an inch, on the medial pinky aspect of the wrist. Apply firm but gentle pressure to locate this prominence. It should feel rounded and somewhat distinct, especially in pronation.
Confirmation.
You'll confirm the ulna head by feeling that small, rounded prominence. It's relatively fixed compared to the wrist bones, but rotates with the forearm. It becomes especially distinct with active forearm pronation by the person, which makes it more easily palpable on the dorsal aspect of the wrist as it rotates into view. This distal radial ulnar joint is crucial for wrist movement and that full forearm rotation, working in concert with the radius.
Great. Okay, we've explored some essential landmarks of the upper limb, the greater tubercle, the epicondyles, the mobile radial head, the olecranon, the ulnar head. Well, we won't dive into every single tiny carpal bone in the wrist or every phalanx in the fingers in detail right now due to time.
There are quite a few.
Yeah. But understanding the general principles of palpating these small bones, feeling for their individual shapes, their positions relative to each other, and any subtle movements at their joints is key. For a truly comprehensive guide to all the intricate bones of the wrist and hand, including the scaphoid, lunate, pisiform, and all the rest, remember our online resource is there for you. Okay, now we move to the lower half of the appendicular skeleton, starting with the powerful pelvic girdle. This provides immense power and support for the entire lower body, acts as a basin protecting internal organs, and forms that robust link between the spine and the legs. Let's begin with the ilium, the largest part of the hip bone, and specifically its iliac crest. That's the part you put your hands on when you put your hands on your hips, right?
Exactly that ridge. For the iliac crest, support the person's pelvis by having them stand, maybe with their hands placed casually on their hips themselves. This often helps relax the surrounding muscles like the obliques and glutes, making the crest more prominent and easier to feel clearly.
Okay, hands on hips. Landmark to start tracing.
Your nearest prominent landmark is the ASIS, the anterior superior iliac spine. That's that distinct bony projection at the very front of the pelvis, the little point you can easily feel at the front of your hip bone.
Okay, the front point. Start there.
Locate the ASIS. From there, trace laterally outward and then posteriorly backward along the very top edge of the pelvis. You're following its distinct curve, covering a significant distance, maybe 10 to 15 centimeters, 4 to 6 inches, all the way around towards your back.
Follow that whole curve. Palpation.
Apply firm but gentle pressure to clearly trace this broad superior ridge of the pelvis. It should feel like a solid, long curve of bone, almost like a shelf running along the top of your hip.
Confirmation.
You'll confirm the iliac crest by feeling that broad, curved, immovable bony ridge along the very top of the pelvis. Since the pelvis as a whole unit is relatively fixed, apart from minor movement at the sacroiliac joints and pubic symphysis, joint movement isn't really applicable for palpating the crest itself. The iliac crest is a major attachment site for many important abdominal and back muscles, playing a crucial role in core stability and hip movement. It's also a very common site for bone marrow biopsies.
Good to know. Okay, next, let's pinpoint that starting point we just mentioned, the ASIS, anterior superior iliac spine itself. You said this is a very important landmark for things like measuring leg length and assessing pelvic alignment.
Extremely important clinically, yes. Support the person's pelvis by having them stand, or often easier, lie supine. That's lying flat on their back with their hips relaxed. This ensures no muscle tension is pulling the pelvis out of its neutral position, which could skew your palpation or assessment.
Supine, relaxed. Landmark to find it.
Your nearest prominent landmark, if you're starting lower down, is the pubic crest, located at the very front of the pubic bone, which is lower down and more central in the pelvis.
Okay, start near the pubic area and go outwards.
You could, or often you just feel along the front of the iliac crest until you find the most anterior point. If starting from the pubic crest, slide your fingers laterally outward and slightly upward, maybe 5 to 7 centimeters, 2 to 3 inches, along the anterior aspect of the pelvis until you hit that distinct bony projection.
Gotcha. Palpation, how does it feel?
Use firm but gentle pressure to locate this distinct prominence. It's often quite sharp or pointed and easily palpable on most people. A clear corner on the front of the hip bone.
Confirmation.
You'll confirm the ASIS by feeling that prominent, pointed, immovable bony projection on the anterior aspect of the pelvis. It's a fixed part of the pelvis, so no joint movement applies. The ASIS serves as a crucial attachment point for the inguinal ligament, which runs down towards the groin, and several important thigh muscles like the sartorius and tensor fasciae latae, critical for both posture and leg movement.
Okay. Now, on the posterior side of the ilium, we have the PSIS, posterior superior iliac spine. You mentioned these often correspond to those visible dimples in the lower back, sometimes called the dimples of Venus.
That's right, they often do. To find them, support the person's lower back by having them stand, or, again, often easier, lie prone face down with hips relaxed. This exposes the posterior pelvis nicely, making the PSIS more accessible.
Prone position again. Landmark.
The crest. Yes, your nearest prominent landmark is the iliac crest itself, which you've just traced. You can simply follow it all the way posteriorly to its very end.
Okay, follow the crest to the back.
Locate the iliac crest. Trace posteriorly backward along the crest to its very end, maybe 10 to 12 centimeters, 4 to 5 inches from the acis, until you reach a distinct bump or indentation right near the sacrum. Apply firm but gentle pressure to feel these distinct prominences. They're usually bilateral, one on each side, and often marked by those visible skin dimples, which can make them somewhat easier to spot and verify visually too.
Okay, feel for the bumps near the dimples. Confirmation.
You'll confirm the PSIS by feeling those two small, immovable, bony prominences on either side of the lower back, close to the sacrum. Again, as a fixed part of the pelvis, no joint movement applies. The PSIS is a key reference point for assessing pelvic symmetry, sacroiliac joint position, and stability, often involved in understanding lower back pain and SI joint dysfunction.
Important for back health then. Okay, moving to the bottom part of the hip bone now, the ischium. Let's find its most prominent part, the ischial tuberosity, which you call the sits bone.
Exactly, because it's what you sit on. Support the person's pelvis by having them sit, maybe leaning forward slightly, with hips flexed. This position makes the tuberosity more prominent as the gluteal muscles, your buttock muscles, are slightly stretched over them, and the weight is shifted directly onto these bony points.
Sitting, leaning forward, landmark.
Your nearest prominent landmark, superiorly, could be the PSIS, giving you a superior and slightly posterior reference point to trace down from.
Okay, start at the PSIS, trace down.
Start at the PSIS. Slide your fingers downward and maybe slightly lateral, outward, about 5 to 7 centimeters, 2 to 3 inches, aiming for the area directly underneath the bulk of the buttocks where you make contact with the chair.
Right under the buttock, palpation.
Apply firm but gentle pressure to clearly feel this prominent structure. It should feel broad and rounded, quite substantial. Exactly what you'd expect a weight-bearing bone to feel like.
Confirmation.
You'll confirm the ischial tuberosity by feeling that large, rounded, immovable bony prominence located directly under the buttocks. This is indeed the bone you sit on, specifically designed to bear the body's weight when seated. As a fixed part of the pelvis, joint movement is not applicable. And crucially, this tuberosity is also the primary attachment point for the hamstring muscles, which are vital for hip extension and knee flexion.
Hamstrings attached there. Okay, we've now explored the major landmarks of the pelvic girdle. The iliac crest, the ASIS, PSIS, and the ischial tuberosity. That gives us a great understanding of this foundational structure. Of course, the pelvis also has other important, often deeper structures, like the ischiopubic rami connecting the ischium and pubis, and the pubic tubercles at the front. For a complete understanding of all these anatomical points, including precise methods for their palpation, please refer back to the detailed guide available with this deep dive. Now let's bring our journey towards a close by exploring the bones of the lower limb, essential for our locomotion and stability. All right, we've arrived at the lower limb. The structure is essential for getting us around locomotion and stability, allowing us to walk, run, jump, stand. Let's begin with the longest bone in the body, the femur, your thigh bone, and its most prominent lateral projection up near the hip, the greater trochanter.
Yes, that big bump on the side of your hip. To palpate the greater trochanter, support the person's leg, perhaps by holding under the knee with the hip nice and relaxed. This helps prevent muscle tension, especially from the powerful surrounding gluteal muscles, from obscuring this large bony landmark.
Relaxed hip, landmark. The crest again.
The iliac crest, the prominent upper edge of the hip bone we just explored, is a great superior landmark. You can feel it easily on your waistline.
Okay, find the crest.
Locate the iliac crest. Slide your fingers directly downward about 10 to 12 centimeters, maybe 4 to 5 inches, along the lateral aspect of the thigh. Apply firm but gentle pressure to feel this large, prominent structure. It's often quite unmistakable, feeling like a large, rounded knob on the side of your hip. You can usually feel it easily when lying on your side, too.
Okay, big knob on the side, confirmation. How do we know it's the femur and not the pelvis?
You'll confirm the greater trochanter by feeling that large, rounded, bony prominence on the lateral hip. And here's the key movement test, similar to the greater tubercle on the humerus. Ask the person to actively rotate their hip internally and externally.
Rotate the whole leg in and out.
Exactly, maybe keeping the knee straight or bent. The trochanter should distinctly rotate forward and backward along with the femur, moving under your fingers. This confirms its position as part of the femur, specifically the top end near the hip joint, and not a fixed part of the pelvis.
Rotation confirms it's the femur. Got it.
Right. And this greater trochanter is a critical attachment site for many important hip muscles, particularly the powerful hip abductors like the gluteus medius and minimus, which keep your pelvis level when you're standing on one leg.
Okay, moving down to the knee now. Let's identify the lateral and medial epicondyles of the femur. These are those prominent knobs on either side of your knee, just above the actual joint line, similar to ones on the elbow.
Exactly. Very analogous structure. Support the person's leg by holding maybe under the knee with the knee slightly flexed. This helps expose the distal end of the femur and relaxes the joint capsule and ligaments, making the bony points clearer.
Knee slightly bent. Landmark.
Your nearest prominent landmark is the patella, the kneecap, which sits right in front of the epicondyles, giving you a good central reference point.
Okay, start at the kneecap.
Start at the sides of the patella. Slide your fingers directly upward and either laterally outward or medially inward, about 2 to 3 centimeters, roughly an inch, to the sides of the distal femur, just above the main joint line. You're feeling for the distinct bony projections on either side.
Feel for the knobs on the sides. Palpation.
Use firm but gentle pressure to clearly locate these distinct bony knobs. They should be quite palpable, although the medial epicondyle often feels slightly larger or more prominent than the lateral one.
Confirmation. How do we know they're part of the femur?
You'll confirm the epicondyles by feeling those prominent bony, immovable knobs on the lateral and medial sides of the distal femur. Ask the person to actively flex and extend their knee bend and straighten it. The epicondyle should remain fixed relative to the thigh, confirming their position on the stationary femur while the tibia moves below.
Stay fixed during knee bending. Got it.
Right. And these epicondyles are crucial attachment points for the collateral ligaments of the knee, the MCL and LCL, which provide vital side-to-side stability to the knee joint.
Important stabilizers. Okay, the kneecap itself, the patella, is our next landmark. This unique bone, you said, kind of floats within a tendon, protecting the knee joint and improving muscle efficiency.
That's right. It's a sesamoid bone embedded in the quadriceps tendon. Support the person's leg, maybe by holding their ankle with the knee straight or only very slightly flexed. And importantly, the thigh muscles, quadriceps, relax.
Relax the quads. Why?
Relaxing the quadriceps tendon allows the patella to be more mobile side to side, which helps confirm you're on it. If the quads are tense, the patella gets pulled up tight and feels less mobile.
Okay, relax the thigh. Landmark.
Your nearest prominent landmark, inferiorly, is the tibial tuberosity, that bump on the shin bone located just below the kneecap where the patellar ligament attaches.
Okay, find the bump below. Trace up.
Locate the tibial tuberosity. Slide your fingers directly upward, about 5 to 7 centimeters, 2 to 3 inches, onto the anterior aspect of the knee. Apply firm but gentle pressure to feel this distinct bone. It should be easily palpable and feel like a flat, somewhat triangular plate.
Flat, triangular, confirmation. You mentioned mobility.
Exactly. You'll confirm the patella by feeling that flat, triangular bone located within the quadriceps tendon, and the key confirmation is its mobility. With the quads relaxed, you should be able to gently push the patella slightly side to side, medially and laterally, and maybe even a little up and down.
Feel it slide a bit.
Yes, that slight passive mobility confirms it. Also, if you ask the person to actively extend their knee, straighten their leg against slight resistance, the patella should track upward and maybe slightly laterally, confirming its position within the patellofemoral joint. This gliding mobility is crucial for smooth knee function.
Very cool. Mobile kneecap. Okay, moving to the lower leg bones now, starting with the tibia, the main shin bone. Let's find its prominent anterior border, or shin crest. This is the very front edge of your shin bone, the part that often gets bumped, right?
Precisely. The one that makes you wince when you walk into the coffee table. Support the person's leg by holding their ankle, just letting the leg relax.
Okay, landmark.
Your nearest prominent landmark proximally at the top is the tibial tuberosity, that bump just below the kneecap where the patellar ligament attaches.
Okay, start at the tibial tuberosity. Trace down.
Start at the tibial tuberosity. Slide your fingers directly downward along the very front edge of the shin for about 20 to 25 centimeters, 8 to 10 inches, tracing its entire length down towards the ankle.
Okay, palpation. How does it feel?
Use firm but gentle pressure to clearly trace this sharp, easily palpable ridge. It's often referred to as the shin bone, precisely because This anterior crest is so superficial and prominent, feeling quite sharp under the skin.
Confirmation.
You'll confirm the anterior crest by feeling that sharp, bony, immovable ridge running prominently along the entire front of the shin bone. As the crest is a fixed part of the tibia shaft, joint movement isn't applicable for confirming the crest itself. This ridge, while superficial and vulnerable to bumps, provides structural integrity to the tibia and acts as an important landmark separating the muscle compartments of the lower leg.
Got it. Sharp, fixed ridge. Now down at the ankle on the inner side, we have the medial malleolus. This is your prominent inner ankle bone, right?
That's the one. Support the person's foot by holding their heel, allowing the ankle to be relaxed.
Landmark. Can we use the crest we just found?
Absolutely. The anterior crest of the tibia is a great landmark. You can trace it all the way down.
Okay, trace a crest down.
Locate the anterior crest. Slide your fingers directly downward along the crest all the way to the ankle, maybe 20 to 25 centimeters. Then, move medially inward to the side of the ankle. Apply firm but gentle pressure to clearly feel this prominence. It's that unmistakable inner ankle bone, usually quite large and rounded, forming the inner side of the ankle joint.
Confirmation.
You'll confirm the medial malleolus by feeling that large, rounded, immovable bony prominence that forms the inner ankle. To confirm it's part of the tibia, which moves with the ankle, ask the person to actively dorsiflex and plantar flex their ankle, point their toes upward and then downward. The malleolus should move along with the rest of the tibia during this ankle movement.
Moves with the ankle. Got it.
Right. This medial malleolus, along with the lateral malleolus of the fibula, forms that stable socket or mortise for the ankle joint, providing the articulation surface for the talus bone of the foot.
Okay, now for the other lower leg bone, the smaller fibula. Let's find its prominence on the outer ankle, the lateral malleolus.
Right, the outer ankle bone. Support the person's foot again by holding the heel, keeping the ankle relaxed.
Landmark. Can we use the medial malleolus we just found?
Yes, the medial malleolus is a perfect reference point. You can just move directly across the ankle from it.
Okay, start at the inner ankle bone.
Start at the medial malleolus. Move your fingers directly laterally outward, across the front, or slightly around the back of the ankle, about 5 to 7 centimeters, 2 to 3 inches, to the outer side. Apply firm but gentle pressure to clearly feel this prominence. It's that unmistakable outer ankle bone. Notice that it often feels sharper and extends slightly lower down than the medial malleolus.
Sharper lower. Okay. Confirmation.
You'll confirm the lateral malleolus by feeling that sharp, bony prominence that forms the outer ankle. It should feel relatively immovable side to side, but will move with ankle motion. Ask the person to actively dorsiflex and plantar flex their ankle again. The lateral malleolus should move along with the fibula and the rest of the lower leg, confirming its position.
Moves with the ankle again. Got it.
Exactly. This lateral malleolus is a key stabilizer of the ankle joint, particularly preventing excessive eversion rolling outward. And it's a very common site for ankle sprains, often involving the ligaments that attach here.
Makes sense why it gets sprained. Okay, now we move right into the foot itself. A really complex and marvelously engineered structure for weight bearing and propulsion. Let's identify the largest bone in the foot, the one forming the heel, the calcaneus.
The heel bone, yes. The foundation of the foot's arch system. Support the person's foot by holding the ankle, allowing the foot to be relaxed.
Landmark. Can we use the malleoli?
Yes, the lateral malleolus, which we just found, is a good starting point.
Okay, start at the outer ankle bone.
Start at the lateral malleolus. Slide your fingers downward and posteriorly backward, about 3 to 5 centimeters, maybe 1 to 2 inches, wrapping around to the prominent area of the heel itself. Apply firm but gentle pressure to clearly feel this large, broad bone. It's unmistakable, feeling like a big, dense block of bone forming the entire back and bottom of the heel.
Big block of bone. Confirmation.
You'll confirm the calcaneus by feeling that large, broad, immovable, relative to itself, bony structure that forms the entire heel. Ask the person to actively dorsiflex their ankle. The calcaneus often tilts slightly upward as part of the overall foot movement, confirming its position. The calcaneus is the very first bone to contact the ground during normal walking gait, absorbing significant impact forces. It plays a critical role in distributing weight across the foot and anchoring the plantar fascia, maintaining the longitudinal arch.
Foundation indeed. Okay, we've covered the greater trochanter of the femur, the essential epicondyles and the patella of the knee, and the prominent malleoli and calcaneus of the ankle and foot. These are just a few of the crucial landmarks that underpin our locomotion and stability. The lower limb, much like the hand, is incredibly complex, with numerous smaller bones in the tarsals, like the talus, navicular cuboid, cuneiforms, the long metatarsals, and the phalanges of the toes.
Definitely a lot going on down there.
Right. While a full exploration of each is beyond our time today, remember that the principles of palpation, using nearby landmarks, carefully observing movement or lack thereof, and applying careful, appropriate pressure remain exactly the same for these smaller structures. And of course, for a truly comprehensive dive into every bone of the lower limb, our detailed guide is waiting for you online. Wow. What an incredible journey we've just taken through the intricate landscape of the human skeleton, really guided just by the power of touch.
It really is amazing what you can feel, isn't it?
Totally. From the very top of the skull, tracing those subtle ridges and really prominent bumps, all the way down to the heel of the foot, the calcaneus, we've explored the bony blueprint that gives us form and function. It's a true testament to nature's engineering.
Indeed it is. And understanding these precise palpation techniques, knowing where to start, how to confidently trace a structure, applying the right pressure, and using those movements for confirmation. It's really more than just an academic exercise.
Right, it's practical.
It offers a really profound way to connect with and truly understand the body's internal architecture. It fosters a deeper appreciation for its complexity, its resilience, right there at your fingertips. It genuinely transforms anatomy from just a diagram into a tangible, felt reality.
And for you, our curious learner listening in, this isn't just about memorizing anatomical facts, is it? It's about gaining a real, tangible appreciation for the structures that allow us to move, to interact with our world, and simply to be. This knowledge can deepen your understanding of movement mechanics, maybe help in identifying potential areas of concern for yourself or others, or simply spark an even greater wonder for human anatomy in your everyday life. Imagine the new insights you might gain about your own body just by applying these techniques next time you're, say, stretching or exercising, recognizing those subtle bumps and curves that define you and enable every single action.
Absolutely. Every bone, every ridge, every subtle groove tells this unique story of form and specialized function. By learning to, listen with your hands, you unlock a completely new dimension of understanding, moving beyond abstract diagrams to a felt experiential knowledge.
Yeah.
This capacity for direct physical assessment is such a powerful tool, whether you're a student, a therapist, an athlete, or simply someone fascinated by the human form. It's a skill that deepens your connection to the miraculous machine that is your body.
So here's a thought for you to carry forward then, a provocative question maybe, to mull over. How might this newfound ability, or perhaps refined ability, to physically locate and confirm these bony landmarks change the way you perceive your own body, or the movements you perform every single day, or even how you approach physical activity and well-being? Consider that silent, intricate dance of your skeleton, constantly supporting, protecting, and enabling every action you take, and how much more intimately you can now understand it simply by extending